I am going to use my abacus to compute the sine of 0.5 radians, and I'm going to show you how that works. To do that, I'm going to take advantage of this, which is the Taylor series of sine. I'm probably only going to use the first two terms for this video to keep things short. I'm going to compute 0.5, and then I'm going to subtract 0.5 cubed divided by 3 factorial, which is 6. So I'm going to start out with 0.5 over here. So there's my 0.5. And now I need to get what 0.5 cubed is. So 0.5 times itself is, of course, 0.25. And then times 5 again. Well, that's 5 times 5, which is 25. And then 5 times 2, which is 10. That's 0.125. So yes, you can do decimals on an abacus. You just have to kind of remember where the decimal point is. If you want, you can use like a row of beads like this just to kind of point out where the decimal point is, but you don't have to. And then I'm going to take this and divide it by 6. So to divide on an abacus, it's very similar to long division. How many times does 6 go into 1, 2? It goes in twice. So I'm going to put a 2 over here. And then take away the 12. And then I still have a 5 left over here. 6 doesn't go into 5. So that's a 0. But it does go into 50 8 times. So that's 8. And then that leaves 2. And then it goes into 20 3 times, of course. So that's 3. And then we're going to have 2 left over. Goes into 20 again 3 times. And it's just going to continue like this. So we're going to have 0.02083333, and so on. So now I'm going to subtract this from 0.5. So to subtract from 0.5, the easiest way to do this is I'm going to take 0.5 and convert it to something equivalent that's much easier to subtract from, which is 0.49999 and 10 at the end. So this is still 0.5. And this last column is 10. And if I carried this 10, I would end up with 0.5 again. So I'm just going to call out what I'm subtracting from over there. I'm subtracting 0.0208333. And so now I have 0.479167. And if I compare that to what the actual answer is, 0.4794255. So I got at least 3 significant digits of sine of 0.5 just with that one step. And if I were to continue by adding x to the 5th divided by 5 factorial, I could get some more significant digits. So that's how you compute sine on an abacus.